Aaron, hey Helen. Appreciate Nicole has her camera on. If Aaron, T Sophie, or I think you're Ryan. Um, sorry,
Oh,
Garrus.
I'm Paris.
Garrus. Uh, if you guys can also have your cameras turned on, I'd appreciate that as well. Um, so today we're going to be talking about a new way to solve algebraic equations, which is called elimination. But before we do that, just as always, we're going to start up with substitution. Just some redoing questions using substitution. So do I have any volunteers who'd like to try the first question here, please? Aaron, would you like to give this question a try?
Wait, when you multiply a positive number by a negative number, does it cancel out the negative?
Did you say can it just when you multiply a positive number by a negative number, it's still a negative number. Um, but before we tackle the first question, let's just do an example here. Um, let's see. Okay, so basically for a negative number, you can think of them. I know in like when I was first taught negative numbers, they used these kind of chips. They had like positive chips, which I think had like a yellow color. And then let's see, does this work? Okay. Okay. So positive chips would have like a green color, and then negative chips they'd have like a red color. All right. So when I was taught uh positive numbers and negative numbers, um that we would for example, you asked whether multiplication of say a negative number would result in another negative number, right? So let's just take this one negative chip here. Um so this negative chip, it just represents -1. Okay, so this is just -1. Um and let's say we multiply this by 4. Aaron, could you try drawing on the screen? What do you think -1 times 4 would be? So if we multiply this by 4, exactly, we would get -4. We'd have 4 -1 chips, right? Oops. Um, so if we multiply -1 by 4, then we'd have 4, sorry, we just have 4 negative chips, right? So, I know when you multiply negative by negative, it gets a bit complicated. I know lots of people can't wrap their heads around that, but just for now, you know that when you have, say, a negative number of -1, for example, and you multiply it by a positive number, the answer is indeed -4. Okay, you got that, Aaron?
Yeah.
Yeah. Okay. Actually, I'll go off on a tangent here. So when you multiply it by a negative, okay, let's say instead of -1 times 4, I'll move off the page, and let's say we started with a +1. All right. Um, I'm not sure how the pen. Okay, let's say we have a +1, and let's say we want to multiply it by -1. Okay, so what the -1 does it flips the chip. Okay, so if it is a positive, it flips it around. So this positive chip becomes a negative chip. Okay, so in this case, if we have +1, um, if we had a positive, oops, if let's get rid of this for a second. If we have a +1, this is a +1, and we multiply this by -1, then what we get left is a -1. Okay, so if you start with a positive chip and you multiply it by a negative number, that means you flip the sign. Okay, and it's the same. If you start with -1 and then you multiply it by +1, then it's just the same as -1, right? So if you multiply -1 by +1, then it's still -1. So we see that the um the commutative property with multiplication, it works as well for both positive and negative numbers. Now, what if, I know you might be asking, what if we had something like -1 times -1? That's usually the hardest part to get your head around. Well, if we start with a -1 chip, right? If we start with a -1 chip, we multiply it by -1, we're supposed to flip the signs, right? So what happens if I flip the signs, Aaron, of a negative number?
It becomes positive.
Exactly, it becomes positive. So once I flip the signs, -1 times -1, this will become a +1. So whenever you see a negative number multiplied by a negative number, you'll you'll see that it becomes a positive number. And in this case, two negatives, once they multiply, they become a positive. So have you heard the saying like the enemy of my enemy is my friend? That's kind of the same concept that goes here, right? It doesn't just work with multiplication. If I did say division here, if I replaced every single multiplication sign with a division sign, these would all actually work out the same. So if I did -1 divided by +1, it'd still be -1. +1 divided by -1 would still be -1. And -1 divided by -1 is also -1. It's also +1. Sorry. So did you get your question answered, Aaron?
Yeah.
I think I'll cover this in a later lesson about positives and negatives, but for now, this is all you need to memorize for now. All right. Okay, so I'm gonna move back to our warm-up questions. Okay. And Ryan, can you please stop scribbling on the screen? Thank you. So Aaron, would you like to start with the first question, please?
5 5x plus 4 times -20 equals -20.
Okay, so where should we start?
Isolating the variables.
So which variable in particular? We see we have, an x and a y. Okay, I should probably change color here.
X.
X. So why do you want to start with x?
We know what the y is.
We know what the y is already. Okay, it's good you noticed that. So we isolate the x. How do we isolate the x? You can draw on the screen if you want. And Ryan, can you erase your content? I know you have a hand raised. Thank you. So Aaron, you can draw on the screen if you want. So you say you want to isolate the x, right? And what's keeping it from being isolated?
Here's a 5.
There's a 5. Okay, but what else is keeping it from being isolated?
Hmm?
What else is keeping the x from being isolated?
There's also there's also 4y.
Exactly. So we have a 4y over here. What can we do with a 4y?
Replace the y.
Okay, let's try substituting the y. Okay, I know replacing. I use replacing myself sometimes, but in standard math terminology, you would use the word substitute. Okay, just as if you have a normal teacher, they become sick, and then someone else comes in, that person would be a substitute teacher, right? So if we write this out again and substitute the y, we have 5x plus 4 times, what's y again, Maren?
Hmm?
What's y?
-5.
-5. Okay, so we have 4 times -5 is equal to -20. So what is 4 times -5?
-20.
-20. Okay, so we have 5x plus -20 is equal to -20. Okay, Ryan, I know you really want to do this problem, but or the next one, but I'll let you do the next one. All right. I appreciate your earnestness. So, Aaron, continue, please. We have 5x minus 20 is equal to -20. What can we do next? I'll move this out of the way if you want. Aaron?
Hmm.
So just continuing on from what you said before, I think you said you wanted to isolate the 5x. Oops. So how can we isolate the 5x right now?
Multiplication.
So what can we multiply by?
0.
0. That's actually not a valid operation to do on these equations because you could technically go like, oh, you see, 1 is equal to 2. If I multiply both sides by 0, I have 0 is equal to 0. So now I have 1 is equal to 2. So this is true. So if you do something like that, that's not exactly a valid it's not a valid math statement. Okay? So I know you might feel tempted to multiply by 0 and go like, aha, these two are equal, but that's it, the end. But this is one of the times where we're actually not allowed to multiply by 0. So let's give that another try. We have the 5x and the negative 20 on this side. What do we do? Aaron?
Mm,
Okay,
subtract.
maybe. Pardon?
Subtract.
So subtract what? Exactly.
Wait, no.
Okay, I think I might be able to make this a bit easier for you. Um, let's say we replace this 5x, okay, with an a. Just for the sake of this problem, let's just say 5x is equal to a. That way, whenever we go like, oh, we found a, we might be able to find 5x, right? Right, Aaron?
Mm,
Yes. So in this case, if I replace 5x with an a, I have a minus 20 is equal to negative 20, right?
yeah.
Yeah. And well, what minus 20 is equal to negative 20? Can you think of any number? Or can you try isolating just for a?
0.
Okay, I think you're getting ahead of yourself. But so how do we just get an a on the left side? What's being annoying? Like, so how do we get rid of this negative 20 on the left side?
Add 20.
Add 20. So we add a 20, and then what do we have on the left side?
With 0.
Not exactly, not yet. So we just have a on the left side, right? Because negative 20 plus 20, that is 0, but there's also the a, right? So do we just have a equals negative 20?
Plus 20. The negative
Exactly.
20 plus 20 equals 0.
Exactly. So we see here that a is equal to 0. All right. So now we know a is equal to 0. What can we do about this 5x equals a? How do we find x? Let's just go down here a bit. So now we know that a is equal to 0. So we have 5x is equal to 0. How do we find x?
5, 5 times 0. Wait,
Okay, so in here it actually is valid to divide by 5 on both sides. Because if let's say I have 0 cookies, all right, and now 4 friends come over, so in total there are now 5 people, and I have 0 cookies to split for 5 people, and unfortunately no one gets any cookies, so everyone still has 0, right? This is just 0 can be divided by anything, but if you divide by the whole other subject. So in this case, we see that x is also equal to 0. So and here this is our answer. X is equal to 0. Thank you, Aaron. Ryan, I think you're pretty eager to do the next question. Which one do you want to do? Do you want to do the one below it, or do you want to do the one?
Next one.
So circle the one you want to do. Let me just move this over a bit. That one? Okay. Uh, I'm just gonna erase some of this stuff right here. How are you gonna do it, Ryan? So what's your first step into solving it?
So you just substitute y into the second equation. Wait, let
Okay.
me just put the pen color so it's okay.
It's 6:15.
Okay. So I see you're using what we learned last class. We learned substitution, and in this case, we see there's a y on both sides. It's actually purposefully listed out this way. You have y on the left side for both of them, and then once you equate them, you just have 2x minus 10 equals 4x minus 8. Continue, please. I'll just move this to the side.
So now you just 2x, bring the 4x over, turns to a negative, equals sign, -8, bring the 10 over, turns to positive, plus 10.
Okay, so you brought the 4x over here, and then you brought the -10, you added a 10 on each side. Okay, so what next?
Now do the subtraction and the addition.
Okay,
To
okay.
next,
So I'm just gonna slow down just a little bit here. Using the same positive tokens and negative tokens we had before. Let's say we have two positive tokens. Okay, we have one positive token, two positive tokens, and now we have four negative tokens. So we have negative token 1, negative token 2, negative token 3, and negative token 4.
it's still negative.
Yes, it is still negative. So when we have
actually,
2x,
positive.
oh, it's positive. I'm talking about the x's right now. So if we have 2x minus 4x, the positives and the negatives will cancel, right? So these two, they'll disappear. These two will disappear. And all we have left are two negative tokens, which is why...
Negative, positive.
No, I'm talking about the 2x minus 4x, right? So in this case, we just have negative 2x. This is where the negative 2 comes from, okay? That was just the equation 2 minus 4 equals negative 2, okay? For those of you who want to see this in a pictorial format. Okay, and then you also did negative 8 plus 10. You can actually just swap them around into 10 minus 8, right? You can that's
Actually, it's a little easier to do the negative part.
Right, it is a bit easier to do it.
You don't even need to swap anything, and boom, you
Well,
got it.
exactly. You don't need to swap anything, but for those who are more used to seeing subtraction statements, this would be the way you can understand negative 8 plus 10, right? So you have 10 minus 8 is 2 because there's just 2 left. And how are you going to finish off, Ryan?
-2 divided by 2, which is x equals -1.
Okay, so you say x is equal to -1.
And let me try.
But before we go on, Ryan, can you verify that if we plug x equals -1 back into our original equation you said here, can you verify that it is true?
Right, -2.
Okay, so we have 2 times -1 is -2, and then subtract 10, that's -12. All right, so I'm pretty sure this is correct. And for the 4 times -1, that's -4. We subtract 8, and that's also -12. So I see you've given yourself an A plus. So we know that x is indeed equal to -1. Are we done yet, Ryan? Are you sure you can give yourself an A plus just yet?
Yeah.
Oh, but what happened to the y?
Oh yeah.
Oh yeah. Okay. All right.
Yeah, just
Well,
gonna delete
remember, once you're done the question, you need to take a look back at what was actually asked, right? We had an x, we had a y, and oh, you so for
I just need to delete the thing I just wrote. Everything.
right. It does look like you fill the screen, but just because you used up an entire sheet of paper doesn't mean you're done yet. Okay, so let's finish it off.
I know. Just substitute -1 into the first or second equation. It just doesn't matter.
And Ryan, just as another thing, the reason I asked you to check whether your answer was correct is because you noticed you have -12 on both sides, right?
Yeah.
-12 here, and you have a -12 here. And do you remember what this used to be? This was 2x minus 10, and then we have y, right? So you found that 2x minus 10 was -12, and you also found 4x minus 8 is also -12.
Oh, I think that's all here.
So what's y? in this scenario.
Wait, let me just use another. Nah, let's delete this.
Okay, thank you. So we have our final answer. I'm just gonna scroll up so that you guys can actually. Oh, Ryan, can you undo that, please? Thank you. So we see our final answer is x comma y. To be strictly specific here, these should be in here too. X comma y is -1 and -12. Okay. So most of the process was trying to find x equals -1, and then once we did the verification, we found out that y is indeed equal to -12 on both sides. So we can ascertain that this equation is done correctly. Okay. Thank you, Ryan. Just make sure when you're doing a question, you verify you finish the entire solution before you submit it. Okay. Okay, I appreciate your enthusiasm, but this is a bit much. Okay. Thank you. So, did everyone follow along with what Ryan just did? I know he skipped some steps, but the question was incorrect. So, Henry, Jagger, do you guys have any questions?
What about throw?
Pardon?
What about throw?
What about who?
Throw.
Who's that?
He's here. Throw.
Earl? I'm not sure. Do I have any other volunteers who'd like to do the third question, please? They do get slightly harder as we go on. Oh, troll. Okay. Yes, troll is here today. We will be having another troll question. But that is for after we're done the warm-up practice questions, okay? Can we have a volunteer to do the third question, please? Ryan, I'd appreciate if you don't scribble across the screen because this is a classroom. Thank you. Henry, would you like to try the third question, please? Okay, I guess I'll ask Garrus. Would you like to try this third question?
No.
No? Why not? I'm actually, uh, Ryan,
Okay.
Ryan, I'd appreciate if you didn't scribble because if you continue this, I will be taking away web references. Okay, Garrus, go ahead.
So y equals 10 plus x, and 2y equals 22 plus x.
Okay, so
Now it appears what we will need to do is like figure out what x is.
okay, so what you just said is true. We want to figure out what x is, or we can try figuring out what y is.
Yeah.
Which one do you want to tackle first?
I think I'll go for x because that's kind of what is actually helping us.
Okay, I think I can see where you're going with that. So
Because y equals 10 plus x, and 2 y's is 22 plus x.
And
So if we figured out what x is, then we could basically divide the sum of 22 plus x into that, and then we'd get 2 y's.
okay. Or
That
if we
can
found out
also-
x,
Yeah.
if we found out x, you could just plug it into here and find out y,
Yeah.
right?
And then we can just add another y to this.
Yes, I think I get what you're trying to say here. So we have a y here, right?
Yes.
It's very useful. Where else do you see a y?
Oh yeah, on the second question, right beside the 2.
Exactly. We see a y over here. And you said you want to keep the x for now. So how can we make this two variables? Because we have a y and an x. We want to somehow get rid of the y. How do you think we can do that, Yours?
If we try to remove one of the y's, that would become unequal.
So I think I'm probably misleading you here, but
Yep.
what I'm saying is, what can we do so that this equation, this second equation here, simply becomes blah 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 plus x equals blah 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 plus x. It doesn't need to be like this, but we just want some number plus x equals some number plus x. That's what we want the equation to become.
Yep.
So remember, I'm pretty sure you were here last class, right, Garrus? Where we learned substitution.
Yep.
Right? And by substitution, you substitute. Okay. Let's say Y is your current teacher. Do you like your current teacher? Garrus?
Sure.
Yeah, your current teacher.
In this class?
Yeah. Okay, let's say you don't like them. All right. Let's say you don't like me and you're like, gee whiz, I hate this guy. I want to switch him out for someone else. Okay.
Okay.
And poof, bada boom. Yeah. Now you have somebody else.
Okay.
Okay, so I'm now the substitute teacher. And
Yep.
in this case, or I can barely see in this, you want to switch out, in this case, instead of switching out your teacher, you want to switch out the variable. All right?
Yep.
So
You look
the
like the
variable,
red bird.
I look like a who?
You look like the girl from the story that the wolf ate her grandma.
Oh no.
Little Red
Maybe
Riding
we should change the troll to a wolf. Well, in this case, you have your original teacher, which is the Y, and he just got eaten. He just got turned into a wolf and is replaced by the X. Okay?
Yes.
So in this case, whenever you see a Y, you can replace it with this big bunch. Okay, this big 10 plus X. So over here,
So 10 plus x equals 22 plus x.
remember
Wait.
there was a 2y in the front.
Oh
So
yeah,
it's
2y.
y. It's 2y. So it's 2 times 10 plus x equals 22 plus x. Okay?
Yep.
And do you know where to go from over here, Gears?
Wait a second. So 2 times 10 plus x.
Exactly. We can tackle the 2 times 10 plus x. And this, we use something called the distributive property, or what you guys might remember more fondly as Angry Birds. Okay?
Yep.
So we set
I
up a slingshot.
remember.
We set up a slingshot at 2, and we shoot our first target. What's our first target, Garrus?
10.
10. So we shoot a slingshot at 10, and we have 2 times 10. What is 2 times 10?
2 times 10, that's 20.
20. Awesome. And that's our first target done. Now let's shoot our second Angry Bird. Eee, and it hits X.
The x.
2 times X.
2x.
2x. So now we have 20 plus 2x equals 22 plus x. Now, what do we do now, Garrus?
Alright. Now we
So,
Okay.
what's our goal? Why are we even solving this equation? Do we just want to shoot Angry
figure
Birds
out
and substitute teachers? What's all this for?
to figure out what x is.
Exactly. We want to figure out what x is. So, how are we going to figure out what x is?
20 plus 2x is equivalent to 22 plus x.
Mm-hmm.
It's 6:30.
And remember,
So,
when we want to...
if 2, so that must mean, wait a second. 2x, and then it's equivalent to 22 plus x.
Right, so 20 plus 2x is equal to 22 plus x.
And then that means we take an x and add it to the 20, technically.
Okay. So how can we bring the 20 plus 2x into just a 20 plus x? What happened in the middle here? What can we do to...
What I'm thinking is basically like, if like the first one is an x, and then so like there's 2x in the first one, but there's only 20, and then it turns into 22 plus x, so that means remove x, and now there's 22. So that
Okay,
must
so
mean x
if we
is
go from
2.
2, you think x is a 2? Is that what you think, Garrus?
Yep.
You think x is a 2? How can you verify that though? So
20 plus
remember,
is
when we
20.
solve systems of equations, we want to isolate the variable, okay?
Yep.
And this variable is kind of scattered all over the place, right? It's like you have
Yeah, it's just like
cup.
x here, x here, x here, x
Yeah,
here,
exactly.
x
X is
here,
everywhere.
x here.
You want to go like, okay, I'm putting you all in one spot. I just want you in this one place. How do we get that to happen? Garrus? So
Alright.
we have an x on the left side and an x on the right side.
Yep.
Do you want them all on the left or all on the right? It actually doesn't really matter. But just I'm just
On the right.
on the right. Okay. All right, let's do it your way. You want all the x's on the right. So how can you force this 2x to go to the right? Like, man, I want this 2x to go on the right. How can I force the 2x to do that?
Two x plus x is 3x.
Not exactly. We can
Not exactly.
to get rid of, how do we get rid of positive 2x, Garrus?
We subtract.
Exactly. So we can subtract 2x. And do I just leave it here? I just have 20.
That's not equal.
Oh, right. It's not equal. What did I miss? What did I miss? It's not equal to 22 plus 2x plus x. What did I miss?
We need to equalize it.
What the heck is equalize it mean?
Oh, like kind of making it equal.
So do you mean we need to do the same things on each side?
Yep.
Yeah. So if we subtract 2x on the left side, we also have to subtract 2x on the right side.
Yep, because
what happens on the right
just
side?
that, it wouldn't be.
It wouldn't be equal. No, sir. So we have 22 plus x minus 2x. The 22, it's the same, right? What
Yep.
is x minus 2x, Garrus?
X minus 2x.
So over here, I think we can use our tokens again. Let's say this is an x, this is one x, and then we have negative 2x, right? And we need to add these together. So positive and negatives will cancel, right?
Yeah.
This positive and this negative will cancel, and what's left?
Another a minus.
Exactly. We just have one minus. So in this case, it would just be a negative x. Okay?
Yep.
And this looks very nice and all. We have all the x's on one side, but there's like a number on both sides, and we want to isolate the x, right?
Yep.
So how can we do that, Garrus? Let me just scroll down a little.
Alright. So we take the x.
And what can we do?
We could wait a second. 22 minus 20 is 2.
It's 2. So we actually from here you can already tell that 22 minus 2 is 20. right?
Yes.
So we know that 22 minus 2 is 20. I know I could work this out properly, but we can move x to the side. So we have x is the same as 22 minus 20, and 22 minus 20 is
22 minus 20 is 2.
Is
So
2.
that means x
Awesome.
equals 2.
Awesome. So now we have our substitute teacher finally figured out that x is equal to 2. Can you verify this for me, please, Garrus?
Yes,
So
I
we
can
have
verify.
2 times 10 plus x. What would this be equal to? So 2
2 times 10. 2
plus
times 10. 2 times
10 plus x. So x was what?
2.
2. So
That's
what's 2
2
times 10?
times 10. 2 times 10 plus 2.
And that is 2 times what? So we do the things inside the brackets. What's 10 plus 2?
10 plus 2 is 12.
Is 12. What's 2 times 12?
2 times 12, that is 24.
24. So we know the left-hand side is 24. No check marks yet. And what about 22 plus x? What was x again?
2.
2. So what's 22 plus 2?
22 plus 2, that is 24.
24. Awesome. So now we see that it is indeed 24 on both sides. Are we done yet, Garrus?
Pretty much.
Pretty much? You think so? Okay, well,
Why?
don't make the same mistake as Ryan did, because the substitute teacher, he may be finished, but
Oh.
I'm back. Okay, so the substitute teacher,
Back.
he's back. I mean, he left, but we still have y to tackle, right? We finished with x. That's done. But what do we know what y is yet, Garrus?
Oh yeah, right. I completely
We
forgot
forgot
about.
y.
Yeah, I
Okay,
spent
so
so.
how do we find y, Garrus? Let me
Ryan,
read some stuff. How do
so
we
we
find
know
y?
that x is 2.
Okay, we know that x is 2, and how do we find y?
So y is technically 10 plus x, and we already figured out what x was, so now it is 12.
Exactly, 10 plus 2 is 12, so we now know that y is equal to 12.
And just to make sure, 2y, which is 22 plus 2, plus 2, that would make 24.
24.
24 divided by 2 is 12.
So we see that.
So
Thank
that
you
means
very much for verifying, Garrus.
12 is 10 plus 2.
Exactly. I'm very glad you managed to verify this on your own without me needing to remind you. And hopefully the rest of you guys also do that as well, because it's very good to verify. It'll save you a lot of marks on quizzes, and just help you catch a bunch of mistakes in general. So round of applause for Garrus, please, everyone. Thank you, Joel. Thank you, Ryan. I think we should have some time to start with elimination today. So let's do that. Oh, something's not working very well. Okay. Do you guys mind? Okay, I think this thing's a bit frozen. Give me another second, please. Okay, yeah, this thing's frozen for now. I have to close this. And bring it back. Okay, we are back.
EA.
So the lesson we'll be covering today will be about elimination. And does anyone have a camera with me right now? I'd actually appreciate if we have 4 people who can get their cameras turned on.
I know
The reason
elimination.
exactly, we are going to learn how to do elimination. I thank you, Garrus, for having your camera on. I think Nicole, you had her camera. You were able to turn your camera on a while ago. I just need a few more people. Okay, Ryan, can you please stop scribbling on the screen? Yeah, this is my last warning. Okay, thank you, Garrus. Actually, so Ryan, Garrus, can you turn your camera just a little bit downwards, so I can see your face. Yeah. Okay, thank you. Actually, all I need you to do is we're just gonna play a round of rock paper scissors, and if whoever wins is out. Okay, on my mark, rock paper scissors. Okay, let's do that again. Rock paper scissors. Okay, rock paper scissors. No, so Garrus, you're supposed to do your own thing. Rock, paper, scissors. Okay, so now Garrus he beats me. Paper beats rock, right? And through this rock paper scissors contest, I will be eliminated from this rock paper scissors contest, and he's the winner, right? So another round of applause, or just hoorays for Garrus being our.
Let me just draw a round of applause.
Well, that doesn't exactly convey the meaning, but it's all right as well. So if we had like a competition, right? In this case, I know we don't really have rock paper scissors competitions, but if we did, Garrus would have eliminated me and he would have been the champion. Since the rest of you guys don't have like cameras on, Garrus is the only eligible one to be the champion. So oh, okay. Well, Ryan, he's now the new challenger. Garrus, would you like to play rock, paper, scissors with him? Okay, on my mark. Rock, paper, scissors. Garrus, I can't see your hand. Rock. Okay, let's do it again. Rock, paper, scissors. Uh-oh. Okay, rock, paper, scissors. I think that was a bit leggy. But okay, let's just say, Ryan, do you mind if you lose?
No.
No, okay. So let's just say Ryan loses, and in this case, Garrus wins again. So in this case, both me and Ryan have both been eliminated, and
everybody turn on
Garrus is first, Ryan is second, and I'm the third. That's how we would rank this this rock paper scissors tournament we have. So Garrus is a champion here. Hooray! He has a rock paper scissors cup.
Why are you drawing me as a stickman?
We're all stickmen here.
Cuz
so Garrus is first, Ryan is second, and
this is not me.
I'm third. I'm kind of sad here. I lost a rock paper scissors match. Yeah, we'll give him a pair of sunglasses too because he's cool. Garrus is a cool kid. So by elimination, I got eliminated. I was the first to get eliminated from the competition, right? Garrus, he beat me, and then I'm like, oh no, I'm out. Then Ryan, he's like, I challenge you. He comes in, he loses, and then he's out too. So in the end, all we have is Garrus. So Garrus,
me and you supposed to like rock paper scissors to know.
Garrus is the last person in the competition. He's the only variable. Okay. And in this case, we basically want to do rock paper scissors competitions with these things too, but it's not random. Okay, we don't do things by random here. Not in this case, anyways. We want to make math easy for us. Okay, and by elimination, we want to get rid of one of these variables. All right, and Henry, Jagger, Kyrian, I know you guys haven't answered yet. Do you guys want to try your hand at one of these questions? So,
could I?
Not. I'll ask someone else first. We haven't really gone through the list yet. So far, I think we've only gone through like 3 people. So I'll give some of these some of the other students a try. Henry, would you like to try this question?
Why don't you give Troll a try?
Pardon?
Why don't you give Troll a try?
Why don't I give Troll a try? Well, Troll has another function.
It's 6:45.
Troll's gonna eat me later if I fail the same question we had last week. So I just got to make sure I do this within time. Okay. So, Henry, you're up. Would you like to try this question? Okay, Jagger, would you like to try this question? Okay, I guess we're a silent bunch today. I'll move on to Kyrian. Nicole. Okay, I guess I will have to go back to Ryan. So Ryan, which variable do you think will win in a
Why?
Why? Okay, so
Because it's
why
singular.
why?
It's easier to eliminate. So why you just minus it? Never mind. I mean, you plus it because
Okay, so you add it.
negative and plus equals negative. So y minus y, when you do it, y is gone. So now you have left.
Oh, okay,
these.
okay. So, Ryan, before you run off too fast, before you run off too far, I'm just gonna say this. It is valid, it's legal, to add two equations together or subtract them. If this is equation 1 and the second one is equation 2, you can add these together to make a third equation. Okay. So in this case, it's the same thing as 2x plus 9x plus y minus y equals 2 plus 9. Okay. And technically, I mean, if you know the answer, you know that these statements are eventually true, but you don't want to conclude this right away. Okay, Ryan? So how would you add these? You have 2x plus 9x. What's that equal to? That's 11x. Awesome. And what's positive y minus y?
Positive minus y equals positive y equals 0.
Equals 0. None. So we see that whatever y is, we don't care. We're like, nah, you're just disappearing. You're being eliminated. So in this case, x is actually very hard to eliminate in this question. You can like multiply this one by 9, and then you can multiply this one by 2, and then you can subtract them, which in my opinion, it just makes everything a bit too nasty. Okay, so in this case, as Ryan noticed, positive y, negative y, they're very easy to cancel out. And in this case, y lost the rock, paper, scissors competition and is out, right? So, Aaron, can you help me with this equation, please? 11x equals 11. What is x?
Wait.
See you, Ryan.
I'm only for the question.
Yeah, okay, no problem. Aaron, you were saying something? So we have 11x equals 11. And how do we find x?
Divide by 11.
Exactly. We can divide both sides by 11 to just get x equals
1.
X equals 1. Awesome. So we know x is equal to 1. How about y?
Are we doing Kahoot today?
I don't think we might have enough time. We'll definitely do Kahoot next time. So Aaron,
Take out.
Maybe. Aaron, how do we find y?
You subtracted 2 by 2.
Okay, so we can substitute the 1 into the first equation. So we have 2 times 1 plus y is equal to 2, right? And this is the same as 2 plus y is equal to 2. And you said you subtract 2 on both sides? Right?
Yeah.
Yeah, so you subtract 2 on both sides. 2 minus 2 is
0.
0. So we have 0 plus y equals 0, which is the same thing as y equals 0. I'd even need to write the first 0 over there. So in this case, we know that y is equal to 0 and x is equal to 1. So if if a teacher asks for like what is xy, then you can just write xy is equal to 1, 0. Okay, so in this case, we know that x is equal to 1 and y is equal to 0. The biggest clue we had that elimination would work is that there's a positive sign and a negative sign over here, right? And it just so happens that when you add these two, the y's will completely disappear, right? And when we solve systems of equations, we want as many variables to disappear as possible. That's our goal. We want to, if let's say we had 1,000,000 equations, we want to simplify it until all we get is one variable. Okay. So in this case, we saw that the positive y and the negative y, they could cancel out once you added them together, and then all you had left was an x. We know how to solve for x, so that's how we solve this question really easily with elimination. Theoretically, you could do this with substitution as well, but it brings in lots of negatives. So, well, yeah, it definitely brings in a few negatives, and it makes things quite nasty, in my opinion. Okay, let's do another one before we end class. Yeah, okay, let's try this one. Garrus, would you like to try this system of equations, please?
Oh.
I'm just gonna move it to a wider spot. Okay, yeah, this should work. So if we look at the x's and the y's, right? Let's say we're playing rock, paper, scissors again. And which variable do you think is more easily eliminated?
X.
X. Okay, so I heard Ryan say X. Garrus, you also said X, right?
Yep.
Yep. So how are we going to eliminate them? Any ideas? So in this case,
Okay.
okay, I heard two voices here. Garrus, you go first.
Separate the x.
Separate the X. What does that mean? Yours?
Basically, just like separate it from
the Y's?
Yep.
So you want it to be like X equals blah blah blah? You want it to look like that? Actually, I think this is a perfect opportunity to see when elimination is useful and when substitution is useful. Okay, so we're gonna do it we're gonna do what Garrett said, and we're gonna isolate the x. Okay, so let's take equation 1. We have x minus 3y equals negative 16. How do we isolate the x, Garrett? So what's being annoying?
Let's see.
So we have x minus 3y, and when we finish, we just want an x. Okay, so how do we just bring this gigantic thing just to an x? What's different? What do you notice? It's basically spot the difference.
Okay, so spot all the differences. First of all, there.
So we notice there's an x over here and there's an x over here.
Yep.
What happened to the negative 3y in the second equation?
Disappeared.
It's gone, exactly. So how do we make it disappear? How do we get rid of negative 3y?
Just like this thing.
Okay, I guess that did also disappear from my point of view. How do we get rid of negative 3y, Garrus?
To get rid of negative 3y.
We can add, because the opposite of minus,
Add.
add
You add 3?
Exactly. You add 3y.
What is that?
Why does that work?
Oh, no. No, nothing. I just saw a bunch of words.
Oh, Ryan, I would really appreciate it if you don't draw on the screen anymore, because it's almost the end of class and there's really no reason to be drawing on the screen at this point, okay? So we have, if we add positive 3y on the left side, what do we do on the right side, Garrus?
You do the same thing.
Exactly, you do the same thing. You add 3y on the right side. So over here we have add 3y. So we have x on the left side. What's on the right side, Garrus?
What's on the right side?
Mm-hmm.
The answer.
Garrus, could you concentrate, please?
So
No.
minus 3y plus 3y
Yeah, it's
plus
positive 3y
3y.
minus 16.
So if you made minus 3y and then added plus 3y, that would technically be like 0, technically.
Mm-hmm, it would be 0. And then you'd also have an x,
You
right?
add another 3y, that would mean it's 3y.
Exactly. So on the right side, we'd have 3y minus 16. Okay. Henry, would you like to do the next part? I know we're technically still doing substitution here, but okay. Thanks, Garrus. Henry, Jagger.
So sad, no blue kid. I mean, Kaku.
Yeah, not for this class. I don't think we have enough time for today. Aaron, how about you help me out here? So now we know that x. Oops. We now know that x is equal to 3y minus 16. We just don't have enough time today. Okay, Ryan. We know that x is equal to 3y minus 16. And what can we do with it? Any ideas?
Find what it is.
Okay, so how do we find it? Do you need any help, Aaron?
Yeah.
Yeah, okay. Ryan, would you like to help Aaron out at this point?
Honestly, I actually don't know.
Are you paying attention to this?
I am kind of hard.
Okay, well, uh, I think we'll tackle this problem next time. Okay, I'll definitely start off our class next time with this problem. I'll show you both how to solve it with substitution and elimination. But since class is almost over today, I'll let you guys go a bit early, and I'll see you guys next week. Okay, see you, Ryan. Bye, Garrus. Bye, Aaron.
I know wobble.
Well, uh,
Bye.
it does need to end at 7. Okay. Bye, Garrus.
Bye.
Bye, Ryan.